Hello, welcome to Dr. T's Algebra 2. In this lesson we are going to look into domain and range. In letter A here we've got an absolute value function. If you remember from the last video, when we want to solve for an absolute value function, we're going to set it equal to plus and minus y. And so we get y is equal to x minus 4. And we can graph that, and then we've got negative y is equal to x minus 4, and in order to get rid of that negative, we're going to multiply or divide by negative 1. So y equals negative x plus 4. Let's now graph that onto a coordinate plane. Graph both of these. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So our first equation is a positive slope of 1, x minus 4, so we've got a y-intercept of negative 4. And it is a positive 1 slope, so our graph looks like that. In our second one, we've got a negative slope, negative 1, and our y-intercept is 4. So it connects with the other one right there at x equals 4. And so for absolute value equations, remember an absolute value of A is always greater than or equal, always greater than 0. Right. So it's never negative. Or I suppose it's always greater than or equal to 0. So there's our absolute value graphed out right there. It's the values in either or both of these which are not negative, because remember the absolute value of negative a is equal to the absolute value of a. And so for each of these values here of x, 3 minus 4 equals negative 1, and then 5 minus 4 equals 1, we've got these values on the x which are equal on both sides of this inflection point there. Right, so the domain of that function is all the x values. And it looks like it goes all the way to negative infinity and all the way to infinity. There are no domain restrictions, so we've got x is all real numbers. Or x less than or equal to negative infinity. Greater than or equal to negative infinity, sorry, less than or equal to infinity. As far as the range goes, however, we have some restrictions because we are only above the x-axis, on or above the x-axis. So we're going to say y is greater than or equal to 0. And so 4 minus 4 is equal to negative 4. That's the same absolute value as 4. 0 minus 4. 4 minus negative 0 plus 4, which is 4. All right, on to the next one. I think people are a little tired of absolute value. We're looking for the domain and range here. If we want to find the domain, it's all of the x values. Is there any x value that doesn't exist here? No, we don't have any asymptotes. We're not divided by an x value. And so we don't have any gaps in the graph. So again, this is x equals all reals. That's our x value, our domain. And then for our range, well, it's going to help if we can do some calculus here. We want to find, looks like negative 2x squared. We're going to have a down-facing parabola here and then some vertex somewhere. Calculus really is the fastest, easiest way to find that vertex point. We could use a graphing calculator and then zoom in and approximate it. And there are a couple algebraic, we can go about that a couple different ways algebraically, but I find calculus to be the easiest way, just taking the first derivative. We get 6 minus 4x. We're going to set that equal to 0 because our slope at that point is 0. And so negative 4x equals negative 6, x equals negative 6 over 4, or 1.5. And we're going to plug that back into the original equation. 6 times 1.5 minus 2 times 1.5 squared, and we end up getting 4.5. Right, 6 times 1.5, we can do the math here, 6 times 1.5, we're going to get 3 equals 1.5 times 2, and that's going to be 3 times over, so we're going to get 9 there. 1.5 squared is 2.25, just like 15 squared is 225. This times 2 is 4.5, so 9 minus 4.5 is 4.5. So that's our maximum value here. 1.5 on the x, 4.5 on the y. And so that looks like y is all the reals beneath and including 4.5. So y is less than or equal to 4.5. There's our range. There's nothing above that for y. Next, what are the x and y intercepts of this equation here? Again, we've got a down-facing parabola. The x and y intercepts. We don't have a middle term, so we've got ax squared plus bx plus c. This is going to tell us how skinny or wide the parabola is and in what direction the parabola is, up or down. Right, so the sign is going to tell us if it opens up or down. The value of a is going to tell us how skinny or wide it is. This is going to shift it left and right, and then this is going to shift it up and down. And so we know our vertex rests on the y-axis, and just to make a long story short, this point here is 0, 4. Right, so we've got a negative down-facing parabola. We're looking then for the x and the y-intercepts. We found the y-intercepts just by interpreting this graph. And again, we can use calculus. We'd get negative 2x equals 0. And so x equals 0. That's on the y-axis, and then 4 minus 0 equals 4. And so our y-intercept then is 0 on the x, 4 on the y. Now we need to find the x values here. Now remember that we can use algebra if g of x equals 4 minus x squared. The x-intercept is where y equals 0. And so we can just set this equation equal to 0. We get 0 equals 4 minus x squared. Move the variables to one side, the constants to the other. X squared equals 4, and here we're going to do the square root of x squared equals the square root of 4. Here's where we can see very clearly that the square root of 4 has both positive and negative values, 2 and negative 2. And so our values here are negative 2, 0, and 2, 0. Right, so we set x equal to 0 and set y equal to 0 to find the x-intercept and y-intercept. Next. For what intervals, for what values, is this function positive? Well, this looks like a line here. We've got our slope and our y-intercept. So if we are to graph that, our y-intercept is 10, and then it's got a slope of 2. So it's somewhere around there. We want to find what that value is because to the right of that, exclusive of that point, to the right of that point, the function is positive. And so our x-intercept, we can find that by setting the y equal to 0. H of x is just another way to say y. 2x plus 10, subtract 10, we get negative 5 equals x. And so this point here is negative 5 on the y and 0 on the, negative 5 on x and 0 on the y. That's our x-intercept. Is the function positive, meaning is y, or h of x, positive there? Well, no, because 0 is neither positive nor negative. And so for h of x greater than negative 5, then it's positive. Or h of x is greater than 0 for x greater than negative 5. For what intervals is it negative? Well, that's going to be just x less than negative 5, not including that tiny, tiny point right there because 0 is neither positive nor negative. Next, for what values of x is each function increasing? Increasing means going up. X squared minus 4x. Let's draw a little table this time. We can find it a different way we found the last few graphically. Let's use a table this time. We got x and y, inputs and outputs. To find the y-axis, the y-intercept, excuse me, to find the y-intercept, we can set x equal to 0. However, this tells us it's going to be shifted. Let's start there. We're going to set x equal to 0. And we get 0 squared minus 4 times 0. So it looks like our y-intercept is 0, x equals 0. I'm going to do the first derivative here just to see what we get. 2x minus 4 equals 0. This is going to be our vertex. 2x equals 4, x equals 2. Then plug that back in. We get 2 squared minus 4 times 2, or 4 minus 8, or negative 4. Okay. Let's try, since we're not using a graph, and again, calculus is really the fastest way to do this, but this is Algebra 2 class, so just take this here at face value. That is our vertex, x equals 2, y equals negative 4. And so we're going to start at x equals 0. If x equals 0, x squared is 0, negative 4 times 0 is 0, y equals 0. And then let's move to x equals 1. 1 squared is 1. 1 minus 4 is negative 3. And then on to 2. 2 squared is 4. 4 minus 8 is negative 4. And then 3. 3 squared is 9. 9 minus 12 is negative 3. And then 4. 4 squared is 4 minus 4 squared is 16, excuse me, minus 16 is 0. And so we've got decreasing. We've got a upward facing parabola like that. And it is decreasing at 0, at 1. So we'll call this 0, x equals 0, this equals x equals 1. And here x equals 2, and then again x equals 1. Sorry, x equals 3, and x equals 4 there. So we are decreasing until we get to x equals 2, and then increasing after that. So I'll just say increasing x greater than 2, decreasing x less than 2. And remember, at x equals 2, it's doing nothing. It's flat. There's 0 slope. It's neither increasing nor decreasing. Next one. This looks like a line. It's going to be going down to the right. Our y-intercept is negative 3. Our slope is negative 2. And so for which values is it decreasing? Decreasing all real numbers. It never comes back up. It never goes back up. It's a line. It never changes direction. Okay, one more. What do the average rates of change of the function, the absolute value of x plus 2 over the intervals negative 2, 0, 0, 3, and negative 2, 3 indicate about the function? Well, let's isolate this absolute value first. So you get y minus 2 is equal to the absolute value of x. And then we want to set x equal to plus and minus y minus 2. So x equals y minus 2, and x equals negative y plus 2. Now let's solve for y again, because we need y in terms of x. So this one here changes to, again, x plus 2, and this one here changes to x minus 2 divided by negative 1, and so negative x plus 2 equals y. Okay, so let's graph that. X plus 2, so 1, 2, 1, 2, 1, 2, 1, 2. 2 is our y-intercept, and we have a positive slope going that way. Then again 2 is our y-intercept. We have a negative slope going that way. And so let's just have a quick look at negative 2, comma 0. This point here, and then 0, comma 3, that's up here, and negative 2, 3. Negative 2, 3. It's going to be up here. Average rates of change. Well, we've got this function here. That's really what we're concerned about. And so if we took 2, we get the absolute value of 0 is 0. 0 plus 2 is 2. We're going to move over 1. We're going to move over 1. So we got absolute value of 1 is 1, plus 2 is 3. Absolute value of negative 1 is 1, plus 2 is 3. We're going to move over here 1, move over here 1. Absolute value of 2 is 2. Absolute value of 2 plus 2 is 4. Same over here, absolute value of negative 2 is 2, plus 2 is 4. And so indeed, this is our absolute value function here. They look like v's, or upside down v's. Okay. Now what is it really asking about here? The average rates of change. Well, the average rate of change in this region here is negative 2. Sorry, negative 1, excuse me. The average rate of change here is positive 1. And I'm not honestly certain what they're talking about because these points aren't on the lines. These are isolated points. I mean, I suppose you could say that at this point, at the 0, at x equals 0, then the average rate of change is 0. At x equals negative 2 here, the average rate of change is negative 1. But why it's worded this way, I'm honestly not certain. Okay, that's going to be all for today. Oh, let's do one more. Let's end on a multiple choice. Which of the following is true for the average rates of change for the function on item 1? We've got to go over here. Which of the following are true about the graph f of x equals negative 4x squared? Select all that apply. And so our vertex is at 0, 0. All right. The domain is a real number. Oh, x equals all real numbers. Yes, that is correct. The range is negative infinity to negative 4. No. So, again, ax squared plus bx plus c. The value and sign of a determine if it opens up and down and if it's narrow or wide. The value of b, of which there is none here, will be a rightward shift or a leftward shift, and the value of c, of which there is none here, will be an upward or downward shift. And so we are at negative 4x squared, we are a downward facing parabola that has a vertex directly on the origin. F is decreasing over the, no. It increases, and then decreases. It's a parabola. The point 0, 0 is the maximum, yes. There are two x-intercepts, no, because 0, 0 is its highest point. It only intersects the x-axis one time, just like the y-axis. All right, this has been Dr. T's Algebra 2. Thank you.